Alright, today we're going to be talking about proving lines parallel. So you're going to have to learn some different theorems to go ahead and prove that your two parallel lines are parallel to each other. Okay, these problems are not very difficult, okay, if you know your theorems, so don't try to make it harder than it is. Okay, so your first theorem is that if you have two coplanar lines that are cut by a transversal, remember a transversal is this guy, so that a pair of corresponding angles are congruent. Remember, corresponding looks like this, these two angles. Then the two lines are parallel. So if you have two corresponding angles, then these two lines would be parallel. Okay, so let's just go straight into the examples. I'll go through a few and hopefully you'll get the hang of it a little bit. Okay, so it says, use the converse of the corresponding angles postulate and the given information to show that L is parallel to M. So we want to prove or show that these guys are parallel. And the information that it gives us is angle 4 is congruent to angle 8. So we know angle 4 is congruent to angle 8. Okay, so we're given that angle 4 is congruent to angle 8. So our reasoning for that is that they are corresponding angles. Okay, so angle 4 is congruent to angle 8 because they're corresponding angles. And since they're corresponding angles, we know that L is parallel to M. L is parallel to M because of the converse of the corresponding angles postulate. And sorry for my handwriting, I know it's not the best. Okay, so L is parallel to M because of the converse of corresponding angles postulate. So these are not very long, they shouldn't take you very long. Okay, so make sure you just take your time and remember your postulates. Okay, so let's look at a few more here. Alright, and this second example, it says that measure angle 3 is 4x minus 80 and measure angle 7 equals 3x minus 50. We also know that x equals 30. Okay, so we need to go ahead and figure out what these two angle measures are. So we can simply go ahead and plug them in for x. So we want to plug in 30 everywhere we see an x. So 4 times 30 minus 80. And 4 times 30 is 120. And if we subtract out 80, we get 40 degrees. So we know that measure angle 3 is 40 degrees. Now let's look at the second one here. We're going to plug in x for measure angle 7. So we have 3 times 30 minus 50. And then 3 times 30 is 90. And if you subtract out 50, you get 40 again. Okay, so we know that both measure angle 3 and measure angle 7 are 40, so they are congruent. Okay, so measure angle 3 is congruent to measure angle 7. Okay, so let's go ahead and mark that on our thing here. And what kind of angles are those? Well, those of course are corresponding angles. So we know that angle 3 is congruent to angle 7 by the corresponding angles postulate. Okay, so sometimes you just kind of have to show through your math that they were corresponding, and then it kind of proves itself. Okay, this last example is similar to the first one. Okay, so we want to prove that measure angle 1 equals measure angle 3 and that makes L parallel to M. So once again, it says 1 is equal to 3, and once again those are corresponding angles. So 1 and 3 are corresponding angles. And because they're corresponding angles, L is parallel to M because of the converse of corresponding angles. Here, let me erase this, this is terrible. The converse of corresponding angles postulate. Okay, so don't overthink these. You just have to know if they're corresponding, that it will indeed be parallel as well. All right, let's try a few more of these. And I want you to go ahead and try 1b by yourself. Okay, so try to prove that one to be corresponding, and then make sure that L would be parallel to M. Okay, so let's try a new one. There are several different terms that you need to know, 3 in fact. Okay, so if you have alternate interior angles, like this guy, if you have alternate interior angles, and if you have a transversal cutting through those, and the alternate interior angles are congruent, then you will have M be parallel to N. If you have alternate exterior angles, like these guys, then they're congruent, then M will be parallel to N. And lastly, if you have same side interior angles, and those are cut by a transversal, and they add up to 180, then M will be parallel to N. Okay, so these are all the things we've been learning lately about all these different types of angles, and if those theorems hold true, then the lines will be parallel to each other. Okay, so make sure that you look at those, memorize them a little bit, and we'll do a few examples to talk about those. Alright, let's look at this next example. We know that 4 is congruent to 8. Okay, so we know 4 is congruent to 8. Well, what type of angles are those? Those happen to be alternate exterior angles. Okay, so they are alternate exterior angles. Okay, and since they're alternate exterior angles and they're congruent, we know that R is parallel to S. And that's because of the converse of alternate exterior angles theorem. Okay, so you just need to memorize these few different theorems, and then these things will go very smoothly. Okay, let's try the next one. Okay, so we know that measure angle 2 is 10x plus 8, and we know that measure angle 3 is 2x or 25x minus 3, and we want to go ahead and plug in x equals 5 for all of those. Okay, so let's go ahead and do that. So the first one, every time you see an x, you're going to plug in a 5. Okay, so 10 times 5 is 50, and 50 plus 8 is 58. Let's try the other one. Okay, 25 times 5 and subtract 3. So 25 times 5 would give you 125, and subtract 3 and you get 122. Now when you have angle 2 and angle 3, these look like same side interior, so we need these guys to add up to be 180 degrees to see if they're going to make things parallel. So we have 122 plus 58, and that does in fact equal 180 degrees. Okay, so since those add up to be 180 degrees, we can go ahead and say that measure angle 2 and measure angle 3 are congruent and are same side interior angles. Okay, so since they are congruent and they're same side interior angles, R is parallel to S by converse of same side interior angles theorem. Okay, so measure angle 2 and measure angle 3 are congruent because of same side interior angles, and because they're same side interior angles, R is parallel to S. Okay, I would like you to try number 2. Just a hint, this is going to be alternate interior angles that you're using. Okay, I would also like you to try 2B. You were just plugging in 50 for both of them, and then looking at measure angles 3 and 7, which are also alternate interior angles, so try to use that one with this problem. Alright, we're going to try one more. Sometimes they're going to give you a proof and you need to write down these statements. And the reasons for each statement. Okay, so let's try this real quick. Let me, I'll just write it out. Okay, so first your proof always starts with what you're given. Okay, so P is parallel to R, that's given. Okay, so that's our first step. Our second step is that angle 3 is congruent to angle 2, and that's because of what theorem? Well, they're alternate exterior angles. Okay, they're alternate exterior angles. Okay, so since you can say that thing, you can also say, and I could have put this in step 2, but I'll put it in step 3, that angle 1 is congruent to angle 3, because that's a given, and you could have put that in step 2, so it's fine. It doesn't have to go in the exact perfect order. Okay, and then lastly, our angle 1 is congruent to angle 2 because of our corresponding angles postulate. And then lastly, since those are corresponding, we know that L is parallel to M because of that same postulate. Now on your test, you won't have anything quite this challenging. It'll be a little bit easier, so you don't have to worry about that. Okay, so we won't try any more of those today. We'll try a few more at a later date. Okay, but just try to be okay with these. Try to memorize all your different properties, and we'll work on them more later.